student, today I am going to teach next chapter, chapter 4, that is determinant. What is determinant? Every square matrix can be associated to a number, means determinant. Every square matrix has a solution denoted by determinant like this A. If matrix A is equal to Aij of n into n order, then its determinant, there are n rows and n columns, these are the elements. Of order 1, determinant A, you write only first element, that is A11. Of order 2, A11, A12, A21, A22. And when you solve, means determinant has a solution, you can solve it. So how can you solve? Diagonally cross multiplication. This is the first diagonal and this is second diagonal. So product of the element of first diagonal A11, A22 after minus sign. Product of the element of second diagonal A12, A21. Is what is the difference between matrix and determinant? Matrix simply it is a arrangement. In matrix, number of elements, quantities are arranged in rows and column wise, but determinant has a solution. So we can find the determinant of only square matrix. First, we will know about the minor and cofactor of any given matrix. Let A is a square matrix. So minor of each element, minor of first element, that is A11 represented by capital M11 suffix, leaving its row and column of this element, leaving it, then write the remaining element between two vertical lines like this, and you can solve it diagonally. Product of the element of first diagonal after minus sign, product of the element of second diagonal. So minor of A21 means this element lies in second row first column, represented by M21. So leaving its row and column means leaving second row first column, write the remaining elements. Similarly, you can determine the minor of remaining element as A33, means minor of this element, leaving its row and column means third row, third column, and write the remaining elements. These are the minor of the elements. Now you can find the cofactors. Cofactors of this element A11 represented by C11 is equal to M11, means cofactor and minus. There is no difference, numerically difference between cofactor and minus. Only difference between their sign. If row plus column is even, here A11 1 plus 1, that is 2, is even, so its minor will be positive. When you find the cofactor, C11 is plus M1. And if row plus column, see second step, row plus column is 2 plus 1 3, so its cofactor is equal to minus sign of its minor. Means if row plus column is odd, then cofactor is equal to negative sign of its minor. If row plus column is even, the cofactor will be with first two sign of its minor. So minor and cofactor, there is only difference in sign. Okay. Now determinant can be explained along any row or any column, solution will remain same. You can expand along any row or any column. Let A is a matrix. When you find its determinant, means solving it, so you can expand along any row or any columns, solution will remain same. Suppose here you are expanding along R1, to write first element of R1 A11 and leaving its row and column right between two vertical lines like this. Then second element, its sign will be negative. Why? This is the element in odd place. Why? Because row plus column is odd. 1 plus 2, 3 is odd, so its sign will be negative. Now leaving its row and column and write the remaining element plus third element of R1 is a 1 3 1 plus 3 4 positive sign leaving its row and column. In this way you can expand along R1. Also you can expand along R2 or R3, C1 or C2 or C3. Solution will never change. Now how can you solve A11? By cross multiplication. This is the product of first diagonal after minus and product of second diagonal. Here also this into this plus third element first diagonal minus second diagonal. Okay, so determinant. When you expand along with cofactor element and cofactor along any row or any column, so determinant with cofactors. So suppose you are expanding along R1 to write first element A11, then into its cofactor C11 plus A12 its cofactor C12, A13 into its cofactor C13. This result is equal to when you are expanding along R2 A21 into C21 its cofactor corresponding cofactor A22 C22 A23 C23 along R3 this. But if you write the element of R1 and cofactor of next row or next column, the result will be different. So means this is the right result which is not equal to A11 C13. Why? Because this is the element of first row and this is the cofactor of third row. So here when you expand or when you find the determinant of any square matrix, then you write cofactor of any row with its elements. Don't write the cofactor of the different row. So you can expand like this. Means determinant when you find the solution of any square matrix or when you find the determinant of any square matrix, you can expand along any row or any column. How to expand you have seen here. Okay.